In 1984 in Netherlands, the company Advanced Semiconductor Materials Lithography was founded. Today we know this company as ASML, and they are basically the most important company on the planet as we speak. So what is ASML and what are they doing, and why are they, in my opinion, the most important company on the planet, and how should you think about this investing opportunity? So to start with the basics, ASML are active in this market of semiconductor manufacturing and actually in one of the most important parts of it, so in the lithography process. Now there are many different kind of lithography processes throughout the years, and these have been changed completely through years depending on what kind of chips has been manufactured. And as we go into more detailed and more expensive and more advanced chip packaging, these different lithography processes are obviously getting more and more advanced as we speak. So ASML are active in the photolithography process, and mainly they are known for the extreme ultraviolet lithography process, or EUV. But also you have to know that one part of their business is also the DUV, or deep ultraviolet. And the main difference is basically the wavelength of the light that they use to print these chips. Now before we go into more detail, we have to know that EUV is the most advanced process right now in the semiconductor manufacturing process, and as of right now ASML is the only company that has this capability. Now there are other kind of competing next generation lithography processes, like for example maskless lithography or nano imprint lithography, but those are not, as we speak, ready for industrial applications. They are simply not financially viable, be it for the cost or technical issues, or also in some cases just sometimes maybe these processes actually work, but the speed at which you need them to work are not competitive. So yeah, EUV is still the main important only process in this stage. So in the process of EUV, you have four main different segments, you could say, or four main different parts that makes the system complete. So you have the optics, then you have the light source, then you have the precision mechanics, and also the software. And ASML is using Carl Zeiss for their optics. And then in 2013 or maybe even 2014, they purchased the American company Kymer for mainly their laser products, so the light source of the system, which is very important. And that's actually part of the reason why ASML's first generation industrial EUV machines got delayed in early 2010s, and we saw them basically entering production almost at the end of that decade. So I think it's in 2017 or 18. I think it's 2018 where we start to see volume production of 7 nanometer process from Taiwan semiconductor industry. Yeah, and then you have obviously the precision mechanics and the software side. The first generation of EUV machines from ASML are the ones using the numerical aperture of 0.33. And we can see that these machines operates at a wavelength of roughly 13.5 nanometers. And then we know that also that these machines are costing anywhere between, let's say, 180 million US dollar to just north of 200 million US dollars. So these are not cheap machines, and very few fabs or companies can actually afford to buy this kind of hardware. And you have to be obviously knowing that if you want to produce at lower nanometers or higher transistor densities, then you need maybe a few of these machines. And if one of them costs like 200 million just to purchase, yeah, it's a very difficult threshold. And we've seen that even companies like Intel has been having difficulties adapting to EUV machines. Now, starting from late next year, I believe, they will also transition to the next generation of these EUV machines that are operating on the 0.55 NA, and this fundamentally change gives you a wavelength of 7 to 8 nanometers light. I think 7.5 to 8 nanometers to be more precise. So it's basically the next evolution in more finer details, And this is the reason why you can also print and get higher transistor density, or as you can see, it's also in more pop culture lower nanometers, let's say 3 or 2 or 1 nanometer process. So yeah, this the wavelength of the light, as smaller as it gets, it enables us to print finer and finer detail. At least in theory, the process in itself is so much more complex. We would need like something like 700 hours, and we wouldn't still not touch the surface. But yeah, just for to not make it too more complicated. And the interesting part with those machines, with the newer generation machines, that they will cost also much more. I think the lower estimates are 300 to 350 million US dollars for one of those machines. And that's a big difficulty, and another step in terms of which companies can afford to actually purchase these manufacturing tools that they are. And one additional problem with the new generation of machines is actually after you have manufactured your wafers, so the wafer manufacturers won't be affected as much by this new change, but any step after the wafer manufacturing will be affected by the more costly machines and the 0.55 Na machines. And we know that, for example, that the tolerances on the wafer, so the surface smoothness, if you could say, on the wafer sheet, has to be even tighter for these new machines. And this enables a new set of kind of problems for the manufacturing side, and what kind of size of the chips you are able to get. Again, we won't go into details into that, but we know that definitely this will affect the cost structure of the chips. So maybe we are being able to enable to manufacture finer details and higher transistor density, but there will be a quite obvious additional cost to this new process. Now, before we get into the ASML balance sheet and earnings report and so on, the financials, we can see that there are a couple of competitors from Japan, Nikon and Canon, especially in the DUV market. Now remember, DUV stands for deep ultraviolet and EUV stands for extreme ultraviolet. So they are not at the high end compared to ASML, but they seem to be in, they have a fair bit of share in the market, but still not anything substantial compared to ASML in the DUV market. Whereas in the EUV market, ASML has basically a complete monopoly, so they own 100% of the market share in this area. As of right now, there is no one even close to being able to achieve what ASML is achieving. Now, before we look into the financial details, we know that there's also a few Chinese companies that start to basically under the surface gain some kind of traction, and one of them is the SMEE. It's Shanghai Manufacturing. Sorry for the last two, I don't know actually, but yes, SMEE anyways. And they are basically the Chinese equivalent of ASML. And we have, of course, SMIC, which is the Chinese equivalent of the Taiwan Semiconductor. So yeah, there is definitely something happening in China. It's very difficult to say how far behind they are. We know that recently, just a couple of days ago, this whole news about Huawei Mate 60 and the 7 nanometer process fully based in China, so basically fully manufactured in China, or mostly on Chinese manufacturing expertise and also hardware. I think it's very interesting because, to my knowledge, the 7 nanometer is basically at the very edge of what you can achieve with the traditional DUV machines, basically the machines that also Canon and Nikon sells. But if you want to go further down, let's say into 5 nanometer and so on, or basically more transistor dense chips, then you need to have some sort of EUV machines, because the process is technically it's not impossible to go below 7 nanometer even without EUV. But the problem is what you saw basically with Intel when they had their struggles transitioning from their 14 nanometer to 10 and 7 nanometer. If you don't have those EUV machines, the amount of additional steps that is required to do to get to those finer details without EUV machines is just exponentially increasing. And if you go even further down to 3 nanometers, at some point it becomes impossible. So yeah, it's not impossible to go below 7 nanometers, but it's getting almost impossible. So that was a bit of technical discussions about ASML, and now let's have a look at the company's financial situation. So we know that ASML is at just around 260 billion US dollar company. Their PE ratio based on last year is just north of 30, so surely it's not cheap, but it's not neither like very expensive. And we can see that if you look at the price chart over the past few years, just to get understanding where we are, you can see that before the pandemic, the company was at 180 US dollars or thereabouts. Then we saw the peak up to 800, and now we are basically somewhere between there around 650 to 660 US dollars. But again, a 260 billion US dollar company, and I mean, I could understand the PE ratio being at this kind of more elevated level, even slightly a bit higher in my opinion, because as we said, they are the sole manufacturer of EUV machines on the planet. Let that just sink in. I mean, there is not a single other company that right now is capable of doing what these guys are doing. So if there ever would be a company deserving, let's say, higher price to earnings ratio, this would definitely be that company in my opinion. And the only, let's say, competition that is gonna arise in the future is gonna be the Chinese in my opinion, because there's nothing even on the US market, even like let's say in the United States, that are so known for their technological prowess, and even them don't have this kind of capabilities. So I think like the only main threat in terms of competition is from the Chinese, and neither Canon or Nikon has the financial or R&D to be able to challenge ASML. So in my opinion, that's not an issue. But the question that arises, I guess, is why should you invest in ASML, and what is your long-term view in terms of, are you investing for 5 years, 10 years, or 20 years? If you're investing for up to 5 years, I wouldn't be too worried with ASML. I don't think this is a big issue at all. I don't expect the Chinese to challenge ASML anytime soon in EUV lithography. But what we can say that if you're a company like ASML, maybe in 10 years onwards, that's gonna be a different story. And to be honest, it's so difficult to speculate about what's gonna happen 10 years from now. But for the current, let's say 2 to 5 years, I wouldn't be surprised if this company is getting even stronger. And you have to remember that I mentioned the next generation machines will cost at least 50% more. I mean, probably could go up to 2 times more. And you would expect that if they're selling these machines at twice the price, they would want to have some kind of higher margins on this newer generation compared to the last generation. And if that's the case, then we could even see higher gross margin for the company. And right now the gross margin of ASML is sitting around, let's say 50% thereabouts. We can see that over the last few quarters it's been just around 49 and let's say above 51 or somewhere thereabouts. So 50% gross margin with the current lineup. But if you again assume a newer machine setup, and once that machine sets, let's say, takes a major share in their output, so maybe in 2025 and onwards, I wouldn't be surprised to see numbers of net sales quarterly getting close to the $10 billion line. We know that demand for any kind of semiconductors is increasing, and as we go onwards, every single product line will actually develop to a, let's say, higher transistor density, hence lower nanometer, and more of your stuff, of your products will be manufactured below 7 nanometer. Sure, maybe you won't have a 5 nanometer let's say fridge or a car in anytime soon, but you definitely have more and more low-end products in terms of electronics like laptops that will be manufactured at 5 nanometer process and onwards. And there is no reason why the demand for the EUV machines wouldn't go up. So I wouldn't, to be honest, given these two facts, that the price of the machines possibly even doubles, and the demand for the EUV machines as we go below 7 nanometer increases even faster, because you have to remember, still as we speak, most of the computers even are made on, like, let's say 7 nanometer and above. So there's going to be a huge volume transitioning from like 10 nanometer, 14 nanometer, 7 nanometer to, let's say, 5 and below. And then of course, let's say in a couple of times you are going to even 2 or 1 nanometers. So yeah, I don't see why this company wouldn't even at some point have above 10 billion sales each quarter, and maybe even gross margin of 55 to 60%. And that could basically, yeah, halve the price to earnings ratio just like that. So yeah, I don't think this company is too expensive, but it's still also like the macros. Currently, everyone is so scared about the macroeconomics, and I understand that. So it's very difficult to say how the price would react in the current, let's say, near term, because it's still at, yeah, almost 700 US dollar, and yeah, price to earnings of 32. So maybe in the short term we could go down to even the 550s, but in the long term, in terms of 2 to 3 years, I don't expect this company to be any bad investment. But again, this is my own opinion, and this is my first video on ASML. So I will definitely keep continuing makes videos about the ASML as well. So thank you for watching, and please make sure to subscribe and put a like, and remind me of anything that I can improve upon in my next video. So thank you again. See you in the next one.